The funny thing about the North American charging standard, or the NACS connector, or the Tesla charging connector, whatever you want to call this, is the further down the road we go with NACS specifically, the more unanswered questions we seem to have. Is this really the one plug to charge them all, or is it the one plug to charge some? And just for a moment, I will plug my own merch if you want a shirt right like this one, or a slightly tweaked version that is one plug to rule them all. You can find those at the merch store. But at any rate, let's get into the NACS connector itself by saying if you have any hard sources with answers to some of the questions I'm going to pose in this video, please reach out to us in the comment section below, or you can always send an email to us at hey@autobuyersguide.com. So that's hey@autobuyersguide.com. Now, the first thing we should mention is that this is a Tesla charge connector. This is not necessarily the North American charging connector, although they are going to be interoperable. And that is probably the first thing we should mention, because the more I have been talking to some of the traditional car companies that are theoretically signing up for NACS, the more questions again I have, because General Motors and Ford and a bunch of other car companies have said off the record, well, we didn't sign up for the connector and the standard that Tesla is using currently for DC fast charging. We have signed up for the new NACS standard. And there is an important distinction. So we should talk about the plug itself just briefly, since I have covered it before. The origin story of the Tesla charging connector in North America is logical. They wanted something to AC charge and they wanted something to DC charge, and this did both because standards were pretty loosey-goosey when Tesla started rolling their first models out in North America. And that's why the origin story here is important. When Tesla cooked this connector up, they decided to use the signaling for J1772, so the same AC charge connector that you find out there for other EVs. The signaling is directly compatible. It's simply a different connector doing the same thing with the same protocols. Then when it came to DC fast charging, they also decided to essentially go off the shelf, and they used CHAdeMO. CHAdeMO is the charging standard that we find on the Nissan Leaf, a number of older EVs like the Soul EV, etc. It was the de facto DC fast charge standard for quite some time, and it is still used in Japan. TEPCO, the Tokyo Power Company there, developed that standard for Japanese market EVs, and it ended up coming to the US. And that is why older Teslas can CHAdeMO charge with a relatively inexpensive adapter. The adapter's not really doing much more than just simply adapting the pins to fit on this plug from that really enormous CHAdeMO plug. And essentially the same thing is also possible with CCS charging, and that's where NACS comes in. Because NACS, rather than being the initial edition of the Tesla plug, which was J1772 and CHAdeMO jammed onto this connector, NACS is actually CCS and J1772 jammed on this connector. Now, rather unfortunately, there is not a lot of solid data on this. If you go to the Tesla website and you take a look at the technical specification sheet for NACS specifically, not the existing connector again, then they do refer to the ISO and DIN standards. DIN would be the German standards agency, ISO International Standards Agency. At any rate, they refer to the international and the German standards for communication on this connector, well, the new connector. So essentially, those are CCS protocols, power line communication, IP framework, etc. Tesla doesn't make any specific commentary on it other than reference those specifications. But that is not what Tesla currently uses at the supercharger stations, because they use the CAN protocol, which is a variant of what we saw with CHAdeMO. Using CAN as a physical layer made a lot of sense at the time, because most of the onboard communications in a modern vehicle are done on the CAN bus. On the other hand, oddly enough, using powerline communication makes an awful lot of sense, because that's the communication protocol that a lot of smart grid applications are using. And most of the recognized smart grid stuff is doing that with IP packets on that physical layer of powerline communication. And that's why we see that in vehicles that support vehicle-to-grid, vehicle-to-home technology, etc. And that is what we're going to see on the NACS connector. So it is an interesting twist, because Tesla is also moving in that direction with their vehicles. Pretty much most Teslas built after late 2021 have native PLC ability on board. If you plug them into a CCS station, they will communicate via PLC and the adapter, of course. If you plug them into a supercharger station, onboard communication with the supercharger is done via the CAN protocol. Whether or not Tesla will abandon CAN is part of the question. And this is one of those unanswered questions that we have, because most of the companies that have adopted NACS that I've been able to talk to, at least unofficially, have said, we are not supporting CAN signaling. We're only going to be using PLC because that is what NACS is all about. It's actually CCS and J1772 jammed onto this connector. And this is critical because up till now, the only Tesla supercharger stations that support PLC signaling are the stations with the Magic Dock adapter. That's probably what's going to be going on when the car companies move to NACS that have announced support for it and support for the Tesla supercharging network. It's important not to conflate those because you can have one without having the other, and that is another thing we should talk about here. At any rate, when that transition happens, those manufacturers are going to be giving you a Tesla Magic Dock-like adapter, and theoretically you can take that to Tesla stations to charge. The question here that's unanswered is, will all the Tesla supercharger stations support PLC? Will they run through their existing V3 inventory and update them all? Or will it only be supported with the upcoming V4 supercharger stations, which will also have the longer cables to enable cars with random charge port locations to charge properly? If any manufacturer out there or any charge company out there could make such a rapid transition, it would be Tesla. Now, 2024 model year vehicles are not going to be supporting the connector according to Ford and according to Volvo. It's going to be 2024 calendar year vehicles that will support charging with NACS. So it is a little further out than some folks had hoped. Also, native NACS connectors, those are coming in calendar year 2025, not model year 2025, which is why vehicles like the Escalade IQ and the Volvo EX30 are going to come with CCS charge connectors native on the vehicle. They will upgrade to NACS at some point in the future, but the connector on the vehicle, at least from the beginning in those 2025 model year vehicles, will still be CCS. But as I said, because this connector uses the same signaling as CCS, it's honestly not that big of an issue. You'll have the adapter just like Tesla owners have an adapter to adapt CCS to their vehicles if their vehicles support it. But this is where some of the questions and the unanswered questions come in here, because I haven't been able to get comment from anybody as to whether the recent announcement by Electrify America that they are going to have NACS connectors at their charge stations, are they going to support NACS or are they going to support Tesla charging standards? And again, we have this slight difference here. If they only support NACS at the moment, the published specification that will soon become theoretically the J3400 connector according to the SAE, so keep all these things in mind. Theoretically, J3400 NACS is going to support CCS and J1772 signaling. That would mean if you owned a Tesla built before late 2021, you might not be able to charge it at an Electrify America station or a Blink station or some of the other networks that are announcing NACS connectors on their stations. This is perhaps less of a problem than some folks think, though, because when I looked at the sales numbers, this may surprise you. Half of the Teslas on the road today were sold after that switchover because Tesla has had a massive boom in Tesla sales in North America. So even though Teslas have been on sale for a decade in the US, half of them on the road, half of them sold actually, so probably more than half on the road, have been sold in the last approximately 2 years or so. I'm eager to see how this situation sorts out because there are a number of possibilities, but let's talk about the most likely scenarios. Most likely scenario is that Ford, General Motors, Nissan, Rivian, etc., all of the companies that have signed up for NACS at this moment are probably not going to support CAN signaling, the older signaling method that Tesla has used basically in every supercharger station up until theoretically the next generation. Although Tesla is likely going to support CAN for some time because half the Teslas on the road still use that. But the new vehicles out there, why install a CAN chip to interface with something that you generally don't need to interact with, especially if Tesla supports both protocols on their hardware for the foreseeable future? That could be the legacy support that they need, but it also may mean those vehicles could be left out in the dust at some point. It's worth noting, though, that Tesla does have a way to add the PLC chip to your Tesla vehicle built prior to those dates. If you want to do that upgrade, some additional upgrades may be required depending on the age of your Tesla, but it is something you can reach out to Tesla and check on. If you're wondering, does your Tesla support PLC signaling? All you have to do is go into your infotainment system and see if the CCS connector is supported. If it is, then you should be good to go. You should work on anything that's coming forward on the NACS front. A question that I was able to get an answer to off record from some companies was that they do not see the NACS switch as being a problem for vehicle to home, vehicle to load, and vehicle to grid capabilities. And that's because none of these companies are actually using a standard at the moment. Theoretically, there is a standard incorporated in some of the global specifications that exist out there for charging connectors, but Ford and GM and the companies that are supporting vehicle to load and vehicle to home, they all kind of go a little off script. Let's be perfectly honest. So for instance, Hyundai and Kia, they offload power via the AC pins on the J1772 connector via an onboard inverter system. It also appears that Stellantis is doing that with their plug-in hybrids, and General Motors is doing that with their EVs as well. Ford goes in a slightly different direction, and they actually offboard power on the DC pins on the CCS connector, and all the inversion for your home backup system is done completely off-board. And that is why that system is specifically for the Ford Lightning, and no other EV will work with that particular setup, because that inverter bank is expecting a particular high voltage DC level from the car, and if it's not within that specification, it simply wouldn't work, period. And obviously communications, etc., is important there. So that's kind of the weird mixed land that we see currently. Ford could always do the same thing with this charge connector right here, because all of the essential components are still here. The two big pins can carry the DC voltage. The power line signaling is done over the two smaller pins on either side of the bottom of the connector. Hey presto, you have the same connection with or without an adapter. So if you bought a new Lightning and you have an old home backup system and Ford still supported the same doohickey, you just plug it in with an adapter and it should work just fine. Unfortunately, again, since none of these are universal standards, it means you cannot plug that same system into a Silverado and expect it to work. You couldn't plug it into a Rivian and expect it to work. You cannot even use the J1772 power offboard thingies from a Hyundai or a Kia on a Stellantis or a General Motors vehicle, even though they're offboarding power in the same way, because they're not communications compatible. So it is still a little bit of a Wild West out there. And that is the other interesting twist with NACS, is that NACS is not defining a specific protocol. In fact, they simply reference in all of these documents the DIN standard and the ISO standard, which have been a little bit of a problem with some EVs in the past, because every engineer's interpretation of the relatively loose standard that we see there has caused some charging problems so far. The relative indecision that we see with NACS may be the reason that some car companies have not chosen to jump on board. The main reason I think that Hyundai and Kia and Genesis have chosen not to hop on board so far is their dedication to high voltage charging. Now, NACS will support what some folks have been calling megawatt charging. It's actually not megawatt charging, it's 600 kilowatt charging, because it's 1,000 volts, 600 amps. That is a ton of power, mind you, so that's double approximately what we see with CCS right now. That does on the surface seem like a good fit for Hyundai and Kia's high voltage EVs, but remember that Tesla Supercharger V3 stations right now don't support 800 volt charging or 1,000 volt charging. They're limited to about 480, 500 volts or so. Also, as some manufacturers have pointed out, the NACS connector is not necessarily less expensive. Now, I know that some folks have put out videos saying that NACS should be cheaper. I know the Munro and Associates have put out some videos there, not disputing necessarily their videos, but the contacts that I have talked to at car companies have questioned whether or not those cost savings are real. When you look at the cost of the connector itself, it's difficult to tell because this hasn't been universally available. It theoretically could have less stuff in it on the connector side. On the vehicle side, things are actually quite similar. You'll notice that we still have a DC contactor, enabler, disabler on the vehicle because the battery contacts have to be opened and closed with CCS or with NACS, so not a lot of difference there. But the mechanism on board the car for this connector is actually quite a bit bulkier than the CCS connector that you see on the vehicle, something that I didn't really think about until actually I saw some of the Monroe & Associates videos. And you can see clearly in these screenshots here that the connector framework behind this, the receptacle framework, is much larger. Part of that is because the latching mechanism for NACS is on the vehicle side rather than on the connector side for J1772 and CCS. So some of these components have just been shifted around. Now, I would not be surprised if connector costs were less expensive with NACS, so charger costs are probably going to be lower because of the volume we have over there, especially from Tesla. But on the vehicle side, it's probably not going to be an enormous difference, if there is a difference at all. Logically, whichever connector has the highest volume and scales up the fastest is going to win. So over time, this is probably going to be the best bet, simply because of the number of companies that have signed on for it. Be sure and sound off down there in the comment section below, and be sure and reach out if you have any solid connections, especially folks that are willing to go on the record with technical details of the upcoming NACS transition. Right now, we have a lot of off-record sources, so we can't really talk too much about where they specifically came from, and a whole lot of assumptions and tea leaf reading and spec sheet reading, etc. that is not necessarily that handy, because what we see on Tesla's website is not going to be what the car manufacturers have signed up for, because they're signing up for the J3400 connector, theoretically pin compatible with this. All those details still have yet to be ironed out, however, by the SAE. It's worth noting that signing up for the NACS connector doesn't necessarily mean that you're also signing up for access to the Tesla supercharger network. And one could logically assume that you could sign up for access to the supercharger network as a manufacturer of vehicles without committing to NACS, because Tesla is going to let you bring your own charge connector adapter to the stations. These charge adapters are not going to be like the Magic Dock, which I actually think would make a bit more sense. Instead, Volvo is going to be giving you a connector. Cadillac's going to be giving you a connector. Ford's going to be giving you a connector. You take that connector with you in your car, and then you use that adapter to plug into the supercharger stations. Obviously, that could be a little bit of a pain there, but Tesla owners are going to be using CCS adapters to charge at certain CCS charger stations around the US, and once these vehicles have NACS connectors on them, they will also be using adapters at older CCS stations. If you have any solid leads, especially leads that are willing to go on record with details of the NACS transition, be sure and reach out to us. And if you are currently shopping for an EV and you're concerned about this transition, my general advice would be, don't worry, there are going to be adapters available for all of the different connectors out there, because everything going forward really is going to be using the exact same signaling. It's really just going to be a physical connector mismatch thing. So think of it just sort of like an extension cord adapter. The one exception to that is who will and won't have access to the Tesla supercharger network. If you are shopping for an EV right now, and that is of extreme importance to you, then you want to buy a Tesla, because they're going to have access to their own network regardless. If you are interested in some of the upcoming crop of EVs from manufacturers that have theoretically signed on, and you really want supercharger access, say for your Cadillac Lyriq or your Silverado EV, you're going to want to wait until the model year where that feature is supported by the manufacturer. They have not committed necessarily to allowing older vehicles to join the party. So if you have a Lightning now, your Lightning may or may not be able to charge at a Tesla supercharger station with or without a Ford or a Tesla adapter. Those details remain to be seen. Tesla does not seem to be pushing the Magic Dock further, which would be the solution for those older vehicles. And we haven't been able to get a comment from Ford as to whether those CCS adapters would work on an older Lightning or not. A lot of that really is going to probably simply be support from the V3 supercharger stations, and whether the manufacturers are adding the communication chip to support CAN natively onto the vehicle. They have so far claimed that is not the case. Or whether Tesla starts adding PLC communication capability to their entire supercharger network. That seems the more likely way to go. So if you're on the fence about that, and again, you want a non-Tesla EV that has access to Tesla's supercharger network, my suggestion, wait till calendar year 2024. We don't know when in calendar year 2024. It may be a decent wait. It could be a full 12 months from the time you're watching this video. But sometime in 2024, we should have more firm answers, because that's when some of those vehicles with adapters will be able to access Tesla superchargers. Then in 2025, we'll have even more clarity, and that is 2025 calendar year. So if you're buying a CX-30 right now, an EX-30 from Volvo, too many vehicles with similar names here, then you might really want to think long and hard about that if you really want to also charge that on the Tesla network. The other networks are improving. Maybe they will be better by the time 2025 rolls around. We just don't know. So again, if that's really of importance to you, keep that all in mind. And again, reach out if you know anything more. See all of you next week.